Right, geometry semester 1 review, topic 2, properties of parallel and perpendicular lines here. So we're just going to simply go through and name all these different types of angle pairs, name all the different examples from the diagram here. So the first is vertical angles. They occur where two lines intersect, and basically they're crossed from each other at that intersection. So the formal definition talked about two pairs of opposite rays. Just think of it though as an x and then opposite sides of the x. So I'm going to type these in. Okay, so we have angle 1 and angle 4. We have angle 2 and angle 3. We have angle 5 and angle 7. And then we have angle 6 and angle 8. Those would be your vertical angles. 1 and 4, 2 and 3, 5 and 7, 6 and 8. Okay, same side interior angles. They're on the same side of the transversal, and they're in between the two lines here. So in between lines A and B, and on the same side. So that's going to be 3 and 5, and then 4 and 6. So one pair of same side interior. It's going to be angle 3 and angle 5. And then the other, whoops. And then the other one will be angle 4 and angle 6. Same side of the transversal. Right, the transversal is the line that cuts through, transverses through the other two lines, cuts through them. Right, so same side, they're both on the left, right, and then they're in between A and B for 3 and 5. And then on the other side, they're both on the right, 4 and 6, and then 4 and 6 are in between lines A and B. Okay, alternate interior angles. Okay, alternate sides of the transversal, but in between those two lines. So 3 and 6. Right, and then angle 4 and angle 5 would be alternate interior angles. Right, corresponding, imagine picking up the intersection point and putting it on top of the other one. So if we picked up this intersection and put it over here, 5 would be on top of 1, 6 would be on top of 2, 7 would be on top of 4, and 8 would be on top of 3. So those angles are in the same corresponding location. So 1 and 5, right? 2 and 6, 4 and 7, or we can do angle 3 and 8, right? And finally, angle 4 and angle 7. Okay, they're in the same corresponding locations. Okay, same side exterior angles. Okay, so same side of the transversal, but outside of lines A and B. So that's going to be angle 1 and angle 8. And then angle 2 and angle 7. Okay, alternate exterior. So we want alternate sides of that transversal. And then exterior, outside of lines A and B. So 1 and 7, and then 2 and 8. Angle 1 and angle 7. Right, and then angle 2 and angle 8. Okay, linear pairs, right, are supplementary and adjacent. They're right next to each other and they form up to form a straight line. So we can do angle 1 and angle 2. Angle 1 and angle 2. Angle 2 and angle 4 would be a linear pair. Angle 4 and angle 3. Angle 3 and angle 1. And if we want to do the rest, we could also do angle 5 and angle 6. Angle 6 and angle 7. Angle 7 and angle 8. And then angle 8 and angle 5. Those would be your linear pairs. 1 and 2, 2 and 4, 4 and 3, 3 and 1, 5 and 6, 6 and 7, 7 and 8, 8 and 5. Okay. Okay, so always congruent are vertical angles, so congruent, okay, would be vertical. Okay, or I guess we should say always congruent is vertical. Okay, if A is parallel to B, So if A is parallel to B, then the corresponding alternate interior and alternate exterior angles are congruent. Okay. For supplementary here, linear pairs are always supplementary. So always supplementary would be linear pairs. Okay, then if the lines A and B are parallel, then same side interior and same side exterior angles are congruent. Are supplementary. Okay, so vertical are always congruent, and then if the lines are parallel, corresponding alternate interior, alternate exterior are congruent as well. Linear pairs are always supplementary, and then if the lines are parallel, your same side interior and same side exteriors are supplementary. Okay. Maybe I should then always, well, actually, if I put a box around each of these, it's a pretty straight line. Okay, that should make sense there. Okay, number 16 here. If complete the following proof. So step 1 is your given. So we need to fill, and we're trying to prove that the measure of angle 1 plus the measure of angle 8 equals 180. So we're using this diagram up here. Okay, so our A is parallel to B is our given, so we can type that in. Okay, so A is parallel to B. That is our given. Okay. We want to prove that the measure of angle 1 plus the measure of angle 8 equals 180. So those are same side exterior angles. We can't use the same side exterior angle theorem or postulate or anything like that. We need to use other things to get there. We can't assume what we're trying to prove is true in order to prove it true. That doesn't make sense. So we need to use an intermediate angle. So they said the measure of angle 5 plus the measure of angle 8 equals 180. So those are a linear pair. Those are supplementary. Okay, linear pairs add up to 180. So we're going to say definition of linear pairs, right, or linear pair theorem. Right, and the problem is we really should say angle 5 and angle 8 are linear pairs first, right, by the definition of linear pairs, and then we should say they add up to 180 by the linear pair theorem. But we're kind of mixing and matching here, which is a little odd, and why sometimes I don't like the consistency of the proofs. Okay, but that's fine. Measure of angle 5 plus measure of angle 8 equals 180. That's because they're a linear pair. So it's really a combination of the definition of a linear pair and linear pair theorem. Okay. The next one, for reason, it says corresponding angles of parallel lines are congruent. So we're looking for corresponding angles. So we went from 8 to 5. We're trying to get to 1. So we probably want to use the fact that make the connection between 5 and 1 here. Okay. So again, we really should say angle 1 is congruent to angle 5 by the corresponding angle theorem, and then say by the definition of congruent that the measures of those angles are equal. But given that they're only giving us 4 steps here, it looks like what they want us to simply say the measure of angle 1 is equal to the measure of angle 5. Right? Corresponding angles are congruent, so their measures are equal. So the measure of angle 5 equals the measure of angle 1. Okay, and then we can substitute that in. We're trying to say that the measure of angle 1 plus the measure of angle 8 equals 180. Right here we have the equation, the measure of angle 5 plus the measure of angle 8 equals 180. But we know the measure of angle 5 equals the measure of angle 1, so we can substitute that in, right? And we can put the measure of angle 1 plus the measure of angle 8 equals 180. And that is substitution. Substitution property. Okay, and then that's what we were trying to prove. Okay, so the lines are parallel, that's given. We know 5 and 8 are a linear pair, so they add up to 180. So the measure of angle 8 plus the measure of angle 5 equals 180. And then since the lines are parallel, 5 and 1, the corresponding angles are congruent. So we know the measure of angle 5 equals the measure of angle 1. So then we can substitute that into our first equation here, and we get the measure of angle 1 plus the measure of angle 8 equals 180. Okay, 17, we're going to essentially do the same thing here. So given is our first step. So A is parallel to B. That's our given. Given. Okay, we're trying to get from 3 to 6. So we're just going to start at 3. I would start at 3. Okay, we know that alternate interior angles are going to be congruent if the lines are parallel, but that's what we're trying to prove. So we can't use the alternate interior angle theorem. So we have to get there some other way. And there's many different ways to do that. I would use corresponding angles maybe, and then vertical. So let's do corresponding. So the corresponding angle theorem, right, is going to tell us that the measure of angle 3 and the measure of angle 8 are equal. So we can say here that the measure of angle 3 is going to equal the measure of angle 8, right? And that's the corresponding angle theorem. Okay, and really the corresponding angle theorem says that the corresponding angles are congruent, so it really should be 2 steps. If the corresponding angles are congruent, we can then use the definition of congruent to say that those angles measures are equal. But based on what they did up here, we're just going to say the measure of the angles are equal. It's kind of like skipping a step, but that's what they're doing there. Okay, we're now at angle 8. So now we can go from angle 8 to angle 6. Those are vertical angles. We know vertical angles are congruent by the vertical angle theorem. So we can say the measure of angle 8 equals the measure of angle 6. Okay. All right, and that is your vertical angle theorem. Vertical angle theorem. Okay. And again, the vertical angle theorem really says that those angles are congruent, not that their measures are equal. So really we should say that those angles are congruent and then use the definition of congruent to say their measures are equal. But we're trying to stay consistent with what they did there. Okay, we now have the measure of angle 3 equal to the measure of angle 8, and the measure of angle 6 is equal to the measure of angle 8. So we can use our transitive property. If two things are equal to the same thing, then they're equal to each other. So here we have two angles that are both equal to the measure of angle 8. Therefore, we know they're going to be equal to each other. So the measure of angle 3 is going to equal the measure of angle 8. And that is your transitive property. Transitive property. Okay, which is what we were trying to show, that the measure of angle 3 equals the measure of angle 8. Okay, and it's confusing here because they're using a congruent symbol, which doesn't make any sense. So we could add another step after this if we want. Let me go back to text box. If I can get another text box and say angle 3 is congruent to angle 6. That is the definition. Right. Okay, so I'm not really sure. It's a little confusing there. Right, you can't say the angle measures are congruent. It's a little bit off. Okay, right? You can't say angle measures are congruent. It's either angle 3 is congruent to angle 6, or it's the measure of angle 3 equals the measure of angle 6. Sorry, measure of angle 6. Okay, so a little confusing there, but don't worry too much about it. It'll make sense on the final, hopefully. All right, and then the last things here for the second topic, for topic 2, 18 and 19 here. So if we look at this one, angle 1 and angle 5. So if I clear this, okay, angle 1 and angle 5 are corresponding angles. Okay, so if the lines are parallel, right, A and B are parallel here. So if your lines are parallel, your corresponding angles are congruent. So if your corresponding angles are congruent, we can set them equal to each other. So this would be 7x minus 20 equals 3x plus 8. Subtract 3x from both sides, you're going to have 4x minus 20. Right? Add 20 to both sides, you get 4x equals 28. Okay, so x is going to equal 7. Okay, and then we want to find the measure of these angles. So the measure of angle 1, right, we're going to substitute in the 7. So 7, and then x is 7. So 7 times 7 minus 20. Right, so the measure of angle 1, that's going to be 49 minus 20, which is 29. Okay, and then we have measure of angle 5 here is equal to 3x plus 8. So 3 times 7 plus 8, which is going to be 21 plus 8, which is 29. And that makes sense because those two angles are congruent, so their measures should be equal. Okay, so 1 and 5 were corresponding, so we set them equal to each other, right, because the lines were parallel. So corresponding alternate interior, alternate exterior are congruent. Same side interior, same side exterior are supplementary. So if we look at 7 and 2, those are same side exterior angles, and we said same side exterior angles are going to be supplementary here, so they add up to 180. So our equation for this one is going to be, that should be an equal sign there, 2x minus 1 plus 9x plus 16 equals 180. Okay, and then we can combine like terms. That's going to be 11x. Whoops, it's starting to slide a bit, but 11x, that's plus 15 equals 180. We subtract 15 from both sides, so we get 11x equals 165, right? And then divide by 11 on both sides. What do we think here? That's going to go in once. It's going to leave 55, 15. X is going to be 15. Okay. All right, and then we need to solve for the measure of angle 2 and 7. Okay, so we can plug in there the measure. Whoops. What happened to, oh, we don't want that. We want this and this. So the measure of angle 7 equals 2 times 15 minus 1. Right, and the measure of angle 2 is equal to 9 times 15 plus 16. Okay, so that's going to be 29, the measure of angle 7 here. right? 30 minus 1 is 29. Okay, and then measure of angle 2, right? So that's going to be 135 plus 16 is going to be 151. Okay, and that makes sense because 151 plus 29 is going to add up to 180. Okay, so the idea here is if the angles are congruent, if they're vertical, alternate interior, alternate exterior corresponding, you're going to set them equal to each other and solve for x. Okay, and then substitute it back in. If they're linear pairs, same side interior, same side exterior, they're supplementary, so you're going to add them up to 180, solve for x, substitute back in. Okay, and that's topic 2. We'll have another video for topic 3 next.